So I guess when I look at the audience, I see what are the guys that really want to change the world and that really want to make greener pavements. So in my case, I'm going to try to make the best of my presentation in order for you to have a good experience. In the last 2 days, we have been talking about the future. We have been talking about a greener future. And for that, we need to have greener mixtures. But I think there is, and we talk about many questions, but I think there is one main question that it was not talked about here. And that is the design of the mixture. That's when we are thinking about greener mixtures, we are also thinking how to design them in order to have an optimized performance for it, okay? So what I bring here is the iMix design. This is something that I developed during my PhD. It were about 5 years. I have to say to the National Laboratory of Civil Engineering, where we are today, this is like my home. I did here all my work. I say thank you for all the support. Here I have one of the persons that were one of my guidance during my PhD, so it's nice to share this podium with you. So this mix design is a new way of doing and thinking the mix design. So it's a new approach. So the question that I bring here today for all of us is how to make better mixtures in only 3 steps. So the first step would be to look at the reality. What we do every day, we use Marshall or we use the giratory compactor to make the mix designs. And the problem of these methods is that they have limitations, obviously. They are not based on the performance of the mixture first. And one of the main problems is that it requires a guy that has a lot of experience doing the mix design. In order, everyone can make a mix design in the lab. But the question is to make greener mixtures. That's a big difference, okay? So when we want a greener mixture, we want a high performance. So we have to have a guy that has a lot of experience doing it to say what is the way that we should go, okay, to put more bitumen, to have a more continuous or more discontinuous mixture, and so on. And it also have other limitations, like the time consuming. Today we are in the 21st century, and we go to the laboratory, and to get the results, we wait about maybe 1 month or 2 months for the results of the mix design. Maybe 2 weeks. But when we open our computers every day, when the computer takes 1 minute, we are already saying, okay, the computer is so slow, I have to buy a new computer. So everyone is rushing, everyone needs to have an answer now. That's the main problem that we live today. So, and the other problem of the methods that we have today is that they require a lot of money to do them, okay? But one of the problems that I experience through my short, but I have some experience in the pavements, is that sometimes we do the mix design, we spend time, we spend money, and we don't get the mixture that we want. So in that moment, sometimes we have to phone to the client saying, okay, sorry, can you send me more materials because I have to make new tests and so on. So that's more time for the transportation, that's more time to make the mix design. And the client is in the other side saying, okay, but I need an answer, and I need it now. So that's a big problem. And this reality sometimes leads us, when we don't make the right decisions, lead us to bituminous mixtures that have failure earlier than we would like it to have. So that make obviously unhappy road users. And for the road administrations, sorry, but you are losing money. And I don't think this is the way to have a greener future with greener pavements, with greener mixtures, okay? So this was the step one. I think it's important to see the reality. So, okay, so which way should we go? That's the question. And we have to innovate. What I tried during my PhD was that. I tried to innovate, I tried to think out of the box, mainly, okay? And I end up in the mixed design, completely different from what we are used to do. So this mixed design, the I mixed design, it's from improved mixed design, okay? It's mainly focused in discontinuous mixtures, and it's a method that is based on the volumetric properties of the material, okay? And it's also based, you can call it based or related to performance, okay? And it has another advantage, is that it allows us not only to make the mixed design, but imagine that you are producing the mixture. You can get the mixture that you are producing in the plant, and you can see what is the curve, you can see what is the percentage of bitumen, and you can make a prediction of the performance of the mixture. So this iMix design, what we do, it's one thing very simple. We look at the materials. Sometimes we get the materials and we don't even look at them, okay? In this case, we look at the materials, we look at the characteristics of the materials, and we insert them in the software that can be a mobile app, okay? So when we put that information in the method that I developed, we are able to make a prediction. And we have to be careful when we use this word, the prediction. We have to think it like it's a scenario, okay? We have a way of, we understand how the mixture will probably behave, okay? We are not facing the values that will be exactly obtained in the lab. But the results, the output that we get is the volumetric properties in terms of the air voids, in terms of the VMA, in terms of the VFB. This is something that we are normally used to use, and it's always a requirement. Make a prediction of water sensibility, resistance to permanent deformation, fatigue resistance, and macro texture. I have to say that during my PhD, I also made the prediction of the fatigue for aged mixtures also, and I'm able also to predict the modulus of the mixture. So you get a lot of information that allow us to make a decision that is something that we are more comfortable with that decision. And imagine the moment where you have to make a decision and you don't have the results from the lab, you have to say something. This is a good tool to help you, okay? Because we look at the input and output, and all this is possible just by using a mobile app, okay? So the question that I'm going to make is very simple. How many persons in this room doesn't have a mobile phone? Please raise your hand. How many people in this room doesn't have a computer? Please raise your hand. But I have a final question. How many of the guys that are here have a laboratory to run the tests? Okay? 2 guys. Okay? The other guys don't have the lab. With this software, it's like having a virtual lab in your pocket, in your mobile phone. So this is what I'm proposing here. Okay? So we can do this anytime, anywhere in the world. So I'm showing you what I consider that will be the future. The guys from the lab, obviously, there are many things to do in the lab. It's not all about the mix design, but the guys from the lab will have more time to make customer care. That's good, okay? They don't have to go to the lab, try a mixture, then try another one, and then try another one till it gets to the right moment, to the right mixture. And I don't know if they are going to get the right mixture, because I think they will not. Because imagine when you are doing the Marshall or the giratoire compactor to make the mix design, I always can ask you, okay, you choose this is the optimum mixture with the optimum composition, okay? But if I put 0.2% more of bitumen, and if I turn the curve, the grading curve, a little bit more discontinuous, would I get a better performance? And that's something that we cannot answer, because that requires, as I said, time and money. And we don't have that time and that money to do that in the lab. So this is a tool that, in this moment, I see it like previously to go to the lab, you are going to make the optimization in your mobile phone or in your computer, and then only after that you go to the lab. But I have a dream, like someone said one day, and I have no doubt that when we start to do a lot of mixtures according to this, and we have about 500 or 1,000 mixtures, and people start to realize, what I get, it's quite similar to what I have in the lab. Maybe the guy will no longer want to go to the lab, okay, to do the mix design. Obviously, as I said, labs are extremely important to do many other things. So this iMix design, it was already made for SMA mixtures with cellulose fibers. The SMA with cellulose fibers were the ones that I used in my PhD. After that, I already have tested in gap-graded mixtures with RAR and thin gap-graded mixtures also with RAR. And we are talking about 30 mixtures already tested. And the results may not be exactly what you get in the lab, but the results always say to me, continue this way, you are going in the right way. I can show you these two slabs are just an example. This one and this one. These slabs were used in my PhD, okay, during my PhD. Which one of these slabs do you think it has the most percentage of bitumen, and a higher percentage of bitumen? This one or this one? This one. It has a higher percentage of bitumen. No, this one? This one has a higher percentage of bitumen. In this case, when we look at this one has only 5.5% of bitumen. And this one has 6.5% of bitumen. But this one, it was when I started the PhD. I was trying to make the mix design of the SMA mixtures, and I didn't quite know well how they work, okay? And during that time, I was trying to, I always read in the lecture, in the international lecture, that, okay, you have to use at least 6% of bitumen. And I was trying to put 6% of bitumen, and I used the limits of the guys from the US, from the United States of America, from Germany, and stuff like that. And we tried to change the curve that we were using, but we didn't manage to put more than 5.5% of bitumen. And when we get to a point, we started to use the mix design in the very early beginning of it, we were able to put 1% more of bitumen and have that kind of macro texture. Okay, so I think for me, at least, it answered one of my questions. It was, how can I put more bitumen in the mixture without jeopardizing all the other properties? Okay. So step 3 that I bring here is, in terms we already see the reality. It was step 1. Step 2, we already see what I'm proposing here. And step 3 is when do we start the greener future? And I can say that we already started yesterday. The mixture that we saw here in the test section was designed according to this mixed design, okay? So when we were in the labs, now I'm going to show you the results that we get from the lab and the ones that I predicted. But the guys from the lab took about 1 month to get the results. I received the materials, and the next day I told them what they would obtain in the lab, okay? So it's a difference of 1 month. And I just need to sit on the computer. So when the first mixture that we did, we used the same curve, the same composition, the same percentage of bitumen and RAR that was used in the test section, but the fraction 0.4, its nature was limestone. So in this case, we are looking at the numbers in terms of the air voids. In this case, we are looking at the numbers in terms of the VMA, and in this case, we are looking at VFB. So the predicted is the blue one, and the real is the one that were obtained in the lab. Okay, so the yellow one is from the lab. So you can see that the results, obviously, they are not above each other, okay? But because that would be awkward, at least. Okay, I'm not Einstein from the pavements. So, but it's pretty similar, okay? So that's the reason, and the same it's for the VMA, and the same it's for the VFB, okay? So when we look at these numbers, to these results, we have to be very careful, okay? Don't look at like I'm going to get what I have in the lab. We have to see it. It's a prediction of the behavior, what it's supposed to happen. The next slide, I show you the resistance to permanent deformation. We tested according to the European standard. And here we have the rating that we have. So here we have what I predicted. You can see that I predicted things that were not made in the lab. Okay, those guys didn't have the time to do it, but I made it in just 1 day. Okay, so this was what was predicted. This is for the WTS. We get these results. You can see that what you do in the lab sometimes got out of control in terms of what is a prediction. Okay, so this is reality. Okay, this is prediction. And in some cases, the prediction is equal to what or similar to what you have in the lab. Sometimes it's not, okay? And the same, it happened here, okay? Then we went and make the same mixed design, but we only change, again, this fraction. We didn't use limestone. We wanted to use basalt to see what were the changes that we have in terms of the performance. And you can see here, you have a gap that is bigger, okay, in terms of the air voids. But somehow, it shows you the tendency. And the same is for the VMA, and the same is for the VFB. The same was done also for the permanent deformation. So I have these results. You can see that the values that I have for lower percentage of bitumen are very similar to the ones that were obtained for higher percentage of bitumen. So I would say that I have to calibrate a little bit better for the use of RAR in terms of the resistance to permanent deformation. So in this case, it was quite similar, and in this case, it was away from what we should of what we had in the lab. The same is for the WTS, and the same is for the PRD. After that, we also managed to make the fatigue, evaluate the fatigue resistance, In terms of the fatigue resistance, in this case, it's above the results that I predicted. But it may not be, but in this case, it is. So you can see that I make the prediction for other percentage. The guys from the lab didn't have that time to do it, but I managed to make that. And I also make the prediction for water sensibility. And in this case, it was you get in the reality, you get, I think it was around 91%, and I get 95%. So it's quite similar. But when we look at these values, we are looking at these values at once. So they help you to say what is the mixture that you should use. And I can, from the results that we have here, we can see that according to this, you should use around 10.5% in terms of the air voids, in terms of the VMA, in terms of the VFB, in terms of the permanent deformation. This was the key to make a decision. In terms, if I didn't have the lab, of course, okay, but we had the lab. So the lab told us, okay, but you can put a little bit more bitumen. There is no problem. But if I didn't had anything, I would use 10.5. And let me just say one thing. 10.5% is not only bitumen. It's bitumen plus the RAR X, okay? So in this case, I should use, without even go to the lab, I would use 10.5% of bitumen. We used in the field 11%, okay? So it's quite similar, and I didn't need to go to the lab. So in the meanwhile, I made the patent registration of it. Last weekend, I was in the Algarve. That's a nice place. I was receiving the third place prize in terms of innovation by our National Society of Professional Engineers. And the next steps for this, I see it like to find the key partners, to find the right investors, to find the right investigation in developing projects to make the implementation of this in the worldwide basis, okay? I think this is one, I'm not going to say that this is the way to a greener future, but I truly believe that this is one of the ways to get there. It's a completely different way of thinking. So thank you for your attention.